Algebra 2, Unit 3.06. We're going to be solving literal rational equations today. And I just want to mention a few things about the quiz. So the quiz will not cover solving literal rational equations. That won't be on there. However, I'm going to spend the first couple of minutes kind of talking about the fuel economy task that we started, because that is a good sort of refresher on some of the things that will be on the quiz. So the quiz will go from Unit 3.01 through Unit 3.05, and that's going to be all one learning target, 3A. All right. So you'll remember this. This is the function for the combined fuel economy. As a reminder, X is the city and Y is the highway fuel economy. So remember that cars have multiple ratings, one for if it's driven in the city and one if it's driven on the highway. We already computed the combined fuel economy for a Volkswagen Jetta where X was 29 and Y was 39, and we found that that was about 33, so I'll just write this here. Answer A was approximately 33.265 miles per gallon. And one thing to notice is that if the city is 29 and the highway is 39, that the average of those two is 34. So the combined fuel economy is a little less than halfway in between. And you might spend a minute or two thinking about why that's the case. But now we want to move on to B, C, and D. So what you're going to do is you're going to go ahead and pause the video at this point. I want you to make sure you've copied down B, C, and D. This is a great prep for the quiz, so don't think of this as like needless work. Doing this question will be really helpful in preparation for the quiz. Make sure you split your paper in two, and then we'll come back and we'll talk. Make sure you have your work on the left and any notes that you want to add on the right. All right, I hope that went well. What we talked about in class was how this function here, this equation, it has rational expressions in it, but as a whole, we'd like to avoid having fractions in our denominator. And so if we can in any way simplify our expression here into just a single rational expression, you can see in B that that's actually something we have to do at the end. So if we can just do that right off the bat, it might make our lives a little easier. And certainly you could do it without doing that first, but I want to go ahead and do that first, and this will allow us to do some work that will prepare you for the quiz. So think about how you could simplify this expression. If you haven't already, pause the video and try it on your own. A couple things that we can do. The first is noticing that we have 1 divided by 1/2 times some expression here. Well, 1 divided by 1/2 is going to be 2. Okay? And then at this point, so now I have 2 divided by 1 over x plus 1 over y. And this is just an adding of 2 rational expressions. And so I encourage you to again pause the video and add these 2 rational expressions. You'll have a common denominator here, so you'll end up, let's go ahead and move over here, 2 over, and the common denominator that you're going to get is going to be x, y, and the numerator that you're going to get, well, think about it, you'll have multiplied by y over y, so you'll have y, and here you'll have x over x, you'll have x, so you'll have y plus x. And I don't need that right there. Okay. So now you're at a situation where you have some value, 2, which is a rational expression, divided by another rational expression. Well, what do you do when you're dividing? It's the same as, instead of dividing by this, you're multiplying by the reciprocal. So go ahead and pause the video and do that. So multiplying by the reciprocal, so what I can do is I can say, okay, instead of dividing here, let's multiply by the reciprocal, which is xy over x or I'll just write it as y since that's how we've written it here, y plus x. And so my final equation, I have 2 times xy, so 2xy divided by, and I have x plus y. Okay? So this is the combined fuel economy, and what I encourage you to do is test it out. Imagine that x was 29 and y is 39. Go ahead and plug it in and see what you get. Now moving on to B and thinking about, okay, if the fuel economy is 10 miles per gallon higher, on average, the highway fuel economy is 10 miles per gallon higher than the city fuel economy. What is the combined fuel economy in terms of x alone? So what we want to do is want to realize that what this is saying is that the highway fuel economy, or in this case y, is equal to 10 plus x, or I can write it as x plus 10. So wherever I see a y, I know that on average, right, for most cars, and this was the case with the Volkswagen Jetta, the highway fuel economy is 10 more than the city fuel economy. So if the city was 29, the highway would be 39. And so what we can do is we can write our equation in terms of only x. So go ahead and pause the video and try that now. And what I'll get, and I'm going to write combined fuel economy, I'm going to abbreviate it as CFE, is going to be equal to, so I have 2x, 2 times x, times y. But y is simply the highway city, which is, or I'm sorry, the highway fuel economy, which is x plus 10. Okay. And in the denominator, I have x plus y, but y is x plus 10. All right. And you might want to simplify just a little bit, so pause the video and try simplifying. And what you'll notice is that your denominator can be written as 2x plus 10. And your numerator, notice that you have this 2 here. So can you factor out a 2 from your denominator? And you can, right? This is actually the same as 2 times x plus 5. Right? And so now I have this 2x times x plus 10. And the 2's can cancel. 2 over 2 is 1. And so now my expression, think about what I have in the numerator. I have x times x plus 10. So I can distribute that in, and I'll end up with x squared plus 10x. And in the denominator, I just have x plus 5. All right, taking a look at C, I know that this form reminds me of what I get when I will divide polynomials. So Q represents quotient. That's the quotient polynomial. In other words, what the quotient polynomial is by divide when I divide. R of x is remainder, and B of x is going to be, of course, what I'm dividing by. And so I can simplify this expression using polynomial division. So go ahead and do that now, and we'll talk about it in just a second. So that's what my setup will look like. And go ahead and try it if you haven't already. Set it up and go. Make sure that you're thinking about what I need to multiply to get x squared, and what I need to multiply x plus 5 by to get x squared. All right, so there's the division. Go through it, make sure you understand each step. I end up with a remainder of 25, of negative 25. So my remainder is going to be negative 25 over, and the way I add this onto my answer, of course, is I take the remainder and I divide it by the divisor. So my expression for the combined fuel economy, I can now write, right? I simplified this expression here, and this is what I got. So I got x plus 5 minus 25 over x plus 5. And you'll notice, of course, that the degree of the remainder is less than the degree of the b of x, or the divisor. And this is actually a fairly simple equation. We've got x plus 5, and then notice that we just have this fairly simple rational expression being subtracted at the end. And this can be very helpful because think about what happens in D as the city fuel economy, X, gets very large. So go ahead and think about that. Write down your answer. Notice that when X gets really, really big, something special happens here. We'll have 25 divided by a really big number. So maybe plug that in your calculator. See what happens when you divide 25 by a huge number, and then pick an even bigger number. What's it getting very, very close to? Well, it turns out that this gets very, very close to 0. So when this is 0, or very close to 0, the combined fuel economy really just ends up being X plus 5. So as the city fuel economy gets very large, my combined fuel economy really just gets close to, combined fuel economy is basically X plus 5. All right, and this was a good refresher. Of course, the quiz will deal with multiplying and dividing and simplifying rational expressions. So now we're going to move on to something new, but nothing that I think is too hard or too complicated. All right, so here are a couple questions that we're going to take a look at. Go ahead and write them down. And the basic idea is that we're solving for a particular variable. So in physics, for example, we have a lot of equations, a lot of relationships that we've noticed, and we sometimes like to isolate a particular variable because we might not know the value of that variable, and so we know the values of others, and so we can manipulate our equations to help us out. So this is a fairly common formula from physics. This is pi times d squared times v divided by 4, which equals q, and q is the maximum flow of water in a pipe, v being the velocity of the water, and d is the diameter of the pipe. So if you imagine, you have some pipe, and you want to know, the maximum flow of the water in the pipe, you want to know the diameter, and you want to know the velocity, right? That's going to tell you how much flow you can have. So we want to solve for v. So pause the video and just try it on your own. Left side of your page, try it on your own. This is just like any other equation. Then once you've finished, I want you to go ahead and write down any questions you have. We'll talk very briefly about it, and then we'll move on to number 2. All right, I hope that went well. So thinking about how to solve for v means we want to isolate v by itself. So we have pi diameter squared v over 4 equals q. And so thinking about the things that I can do, the first, I want to isolate v. I'm going to need to get these constants, this pi and this 4, onto the other side. So I want to remove them from this side, which means I can divide by pi and multiply by 4. I can do that on both sides. Okay. And so pi over pi is 1, 4 over 4 is 1, and now I have d squared v is equal to q times 4q, over pi. I'm almost there. I now just need to divide by d squared on both sides. And when I divide by d squared, let me actually back up for a second. Instead of dividing by v squared, we can think about multiplying by 1 over d squared. It's the same thing, but it will help me on the right side really envision what I'm doing. Okay, so 1 over d squared times d squared is 1, and so I'm left with v on the left side, and on the right I have 4q times 1, which is 4q, divided by pi times d squared. Yeah. And so the velocity is equal to 4q over pi times the diameter squared. All right, so what I want you to do now is go ahead and try this second one, solve for r here. do the best you can. I'll say just a couple things about it, but for the most part, I think you should be able to try this on your own, struggle a little bit through it. And if you want some extra practice, I encourage you to go and solve this equation that we talked about for a different variable. All right, I hope that went well. What I want you to think about, and I'm not going to give you too much on this, I want you to think about how you would take r from the denominator to the numerator by multiplying by r over 1 on both sides, multiplying by r on both sides. And so now you're in a situation where you have r times something, and you can just divide by that something, and I want you to take it on from there, but we'll talk tomorrow a little bit about it.